Welcome to Substrate Seminar, guys. Super stoked to have Pierre and Green from the OpenBrush team right here. Welcome, guys. How are you guys feeling today?
Hello, guys. Feeling well.
Yeah, me too.
Cool. This is actually the first Substrate Seminar of 2022, so pretty stoked to have you guys kick things off.
Yeah, and 2022 will be a huge year for our space, so it's a nice start.
Yeah. Your project is sort of, would you describe it like kind of early stages? You're still in I don't know, how would you describe like the state of OpenBrush right now, actually?
OpenBrush is quite advanced already, but I'm more talking, we are waiting for a palette contract to go live on Parity.
Yeah, that's super exciting. Super exciting. Okay, before we like jump right into things, and I'm guilty of kind of wanting to just get started here. I do have like a quick update here, which is that I created a new updated Google Calendar link for Substrate Seminars. So a little bit of housekeeping. I'll share this link in the chat so that you guys can like keep updated with basically all of the up and coming Substrate Seminars of this year. And with that being said, there it is in the chat. And without further ado, I'm stoked to present to you guys what the topic is today for Substrate Seminar. First off, I'm Sasha Lansky. I'm the developer advocate at Parity Technologies, where we focus on teaching people and developers how to use Substrate and the tools that are available within the frame library to use Substrate and build Substrate-based blockchains. Today's a bit of a fun one because we don't usually have like smart contract specific stuff within Substrate, because Substrate is a language, it's a framework whereby we can build all sorts of different blockchains and not necessarily smart contract focused. But there is a special palette that enables building smart contracts very easily with this programming language called Ink. So OpenBrush actually is a library to build Ink smart contracts. It's got standards that it basically contains the Polkadot Standard Proposals and the different extensions to make it very easy to build the smart contracts with Ink. So it's basically compared to the OpenZeppelin for the Substrate framework. So without further ado, I'm super excited because there's not only going to be a presentation about what this library is and how you can use it, but Green will be jumping into a live coding demo of exactly the things that you need to know to get started with using OpenBrush. So why don't you guys kick it off?
Okay, let's go.
Cool.
First, I will share in the chat just the slide I will share right now. There is some useful link on it, so
Sweet.
You guys can have a look. And let's start. Everybody can see my screen?
Yep, I can see your screen.
Okay.
Awesome.
So let's kick it off. I will present OpenBrush, a library to build Ink smart contract. Some words about our team, Supercolony. We are a venture studio that create, fund, and support Polkadot and cross-chain companies. Some breakthrough around last year, we created the first Polkadot Standard PSP. We funded and built OpenBrush. We are building Ink smart contract commercial project. We are important contributors to Ink repo and Substrate repo. And we are the voice of WASM to push adoption of it in the space. About OpenBrush library, what does it provide? Some feature list, the default implementation of standard PSP22, for example, fungible token, non-fungible token, and multi-token. For them, the standard is still, we are still working on it. It will be accepted, I think, in the future months. Useful contract that implement common logic. So that was inspired by OpenZeppelin. So enable access control and guard and so on. additional macro, wrapper run traits, we'll talk about it, and a custom modifier definition that should really simplify and speed up your development process. And also an exhaustive and up-to-date documentation. It's really not a developer joke. We are really making, every time we create a new version of OpenBrush, we really make sure documentation is up to date. So please have a look. It's really exhaustive. About today's seminar, what we will demonstrate, like 7 things, how to quickly reuse an implementation of PSP22. Then we'll use and implement Pausable. We will override the default implementation of before token transfer. We'll use a wrapper contract around this PSP22 to demonstrate cross-contract calls. We will show 3 different options to structure your project. We'll talk about wrapper run traits. And for integration test, to demonstrate the flow and cross-contracts call, we will use Wetspot and Europa from Patract. I think if you are in Ink or smart contract development, I think you know test products. So what will be today's example? We will have 2 contracts. One contract will be an USD token. It will be a basic PSP22 with a Pausable extension. It will serve as underlying token. And in the example, any user is able to pause transferring of tokens. So mind that it's really not a production example. It's only for example purpose. Then we will have a wrapped USD. It will also be a PSP22, and we will create a custom wrapper trait around it that will act as a wrapper around this USD token. Basically, it will have 2 functions. One function deposit, where you can deposit a USD token and get a wrapper token in exchange, and one where you provide wrapped token and you get a USD token in exchange. We will go through like 3 structure example. First thing, minimal structure. It's suitable for a small size project for a contract that will not have cross-contract call. So it will have no usage of wrapper run trait, and all contract logic is in one file. The second one will be a trait structure. So trait level implementation. It's suitable for medium-sized project, and it's good feature for contract that needs cross-contract interactions. And the contract and the contract logic will be on separate file. And then the universal structure, which is the best structure in my opinion. It's suitable for big size project, and you will have contracts, traits, and implementation all in different files. About today's speakers, so I'm Pierre, I'm Rust engineer, and Green, he's a Rust core blockchain engineer, and we are both working at Supercolony.
Oh, Pierre, I think you were supposed to go to the next slide.
I mean the next slide. Maybe my internet's not so good. What do you see?
Oh, now it's good. Now it's good.
Okay.
Cool.
Then next slide. WASM conference. So it's a really important announcement. I think if you are here, you are really interested about WASM, and our company, we are working with Treasury from Polkadot to have a 1-day dedicated virtual event targeting WASM ecosystem. So everybody from the space will be here. Parity, Asta, Hydra, and many other teams, and we will really talk about the future of WASM. So if you are interested about it, please scan this and find more information. I think you don't want to miss that if you have interest in WASM. And lastly, just some links about our repo or our documentation website and so on. And I think without further ado, let's start coding.
Yes, I will share my screen now. Okay. Do you see my screen? Yeah.
Yes, I see.
Okay.
But it's not really Zoom, but okay, let's go. How to do it?
Okay. So we prepared a repository that contains the structure for today's contract. It also contains tests, which will it contains integration tests.
Wait a sec, Green. I think that we're seeing your screen in split view, so it's really small on the side. Maybe unshare it and try again.
Okay. And share again.
That's better. Cool. Yeah, and so everyone here, like, feel free to make the most of being live and use the ask a question box. I'll do my best to sort of interrupt if it's appropriate during the demo. So if there's any questions you have, anything that's not clear, I'm sure Green and Pierre will be really happy to answer your questions.
Yes. Okay, so we prepared integration tests to verify that contracts works correct. If you want to try to run it by yourself, first you need to install all dependency for Redspot, and also you need to install the latest Europa Node. At the moment, it is 0.3.6. And I will start the node now because we will use it later. Then we will try.
So, Pierre, for those who don't really know what Europa Node, what a Europa Node is and Redspot is, can you maybe briefly explain what these are?
Europa is a substrate node with contract palette that was designed for test purpose. So it makes integration tests really fast. There is no such thing as block time or something like it's really fast. So it's just a substrate node for tests.
Sweet.
Yes, I will put link on it here. Redspot, it is a framework for integration tests. Maybe like Red Hat in Solidity or another framework, I forgot the name, but it is a framework for integration tests. And I think it's enough to describe what is it. Yeah, in README you can find how we can install everything required for testing. And now let's start coding. So first of all, we need to create a cargo toml for our contract. It should contain all dependencies which we will use. So, for example, in OpenBrush documentation, we created a default template with what dependency you should use. So we can copy it here. And now we only need to write an information related to our package. So it is name of our contract, version of contract, edition which you should use, authors, but and another part, create type of the contract. So if it is a contract that you plan to deploy, it should has CD lib type, and also we need to specify an input file for our contract. So here we will use librs. So let's create that file. Okay. Also, in the documentation of OpenBrush, we specified that to use ink, you also need to add some additional stuff. We need to use no std definition because it should enable some stuff from ink, and also to use OpenBrush, you need to enable unstable feature, mean specialization. And yeah, after we should define the body of the contract. We will use brush contract macro. That macro is similar to ink contract macro. But under the hood, it is ink contract macro, but it also adds some additional stuff provided by Brush. So it will expand the implementation of the trait. We will see it later. So we define a new body of the contract. Let's use OpenBrush documentation to import everything related to PSP22. So first of all, we need to import the implementation of PSP22. For that, we should enable features in OpenBrush crate, features PSP22. After, we need to import the stuff related to PSP22. We want to import everything because we want to import an implementation of that PSP, and also we want to import traits and everything what is defined in OpenBrush. So all that steps are described in the documentation. And let's create a structure of the contract. So to create, you need to define a public structure. Let's call it contract for now. And it should be marked with ink storage. And also, for now, we want to derive a default implementation. It means that we can create an empty structure of our contract. And let's talk about PSP22 storage. PSP22 storage, it is a macro. It is derived macro, which will inherit the implementation of PSP22 storage. It is a very simple macro, and it is very simple trait. For example, it is defined in OpenBrush. It is defined in OpenBrush. It is trait with two methods, get and get mute, which will return a PSP data type that contains 3 fields. So we derive the implementation for that trait, and also we marked that field in our contract is PSP22 data. So that will generate the implementation for trait, and that data contains fields that we will use in implementation of PSP22. So, yeah, do you want to ask something?
Yeah, and of course you can add anything you want in the storage if you need something or more, right?
Yeah. In OpenBrush, we described how you can, for example, add additional field like hated account, and then don't do transfers to that account. So if someone do transfer to that account, it will be reverted, that transaction. And in current example, we will a pausable logic later. So we will see how it works. By this line, we inherited the default implementation for PSP22 trade. So it is a standard for a fungible token. It has a list of methods, and OpenBrush provides the implementation for that methods. So we inherited it by that line, And now let's create a constructor for our contract.
Green, that's mean in the line 15, 15 impl PSP22 for contract. That's mean that all the underlying function of the trade, when you will build the contract, will create an inc message and will be callable function, right?
Yeah.
Basically, implement everything in one line.
Yeah. It is the place the brush contract macro expands the implementation. So it will, as you mentioned, yes, it will create inc message for each function, and we'll put the default implementation, define it here. So yeah.
Okay, thanks.
Okay, and let's define a constructor. Let's define simple constructor for now, which will return only empty contract. And let's try to build it to verify that we imported everything correctly. So cargo contract will release contract. Okay, it says that we didn't define cargo toml for another contract. Let's copy paste it and rename. We will update it later. Wrapped is the. For now, we only want to verify that it works. Okay, and
so here you are using cargo contract, right?
Yeah, it is described in official in documentation. So if you want to build your contract with, contract with inc, you should use cargo contract. We are using the latest version. Cargo.
Okay, so basically OpenBrush use exactly the same tool as inc.
Yes. At the moment, again, I did an error here. Constructor. OpenBrush at the moment, OpenBrush use not the latest inc. It use the inc RC6 version. Yeah, we are using the previous release, RC6, because RC7 has has an issue that breaks the usage of traits. Then OpenBrush, the main idea of OpenBrush to use traits. Okay, yeah, we reused the default implementation of PSP22. You can see it builds. So let's now customize it.
Okay, so right now we can say that you finish implementation of PSP22, right?
Yes.
Okay, cool.
Balance. So let me. Our constructor will mint initial supply. Expect should mint init supply. When creator mint function requires two arguments, so how much to mint and which account should get minted tokens. So we want that caller of the constructor will get initial supply of tokens. Yeah. So self-env caller, it is current caller of that method. And we will mint initial supply of tokens for that contract. We also can try to build it to verify that everything works. And oh yeah, it requires type explicit type here. Yeah, okay, it works. Now we want to also inherit the implementation for Pausable modifier. It requires enabling of Pausable feature. So let's enable it here.
Green, can you explain what those Pausable is for?
Pausable allows let me okay, let's force indexation, and yeah, already it is already indexed. Okay, Pausable provides one public method, is contract paused or not, but it also provides two internal functions that allows you to pause or unpause a variable. And in term of current example, we want to be able to pause transfers of BSP22. So we want to we already imported stuff related to Pausable. Now we want to inherit implementation for Pausable storage trade, and for that we need to mark a field in our contract. So we our contract will have a new field, pause, with Pausable data. It is type, and that structure contains only one boolean, paused, which we will use to identify is our contract paused or not. And let's inherit the Pausable trade. It provides one public message. And now we will I will show you how we plan to use it. OpenBrush also provides additional traits related to internal implementation. It is called in the name of the public trait and internal suffix. So, for example, here, internal trait contains before token transfer. That method is called before each transfer of BSP22. So we have transfer from method, and before each transfer, we will call that function. And
okay, so inside the body of this function, you can really add any custom logic that will be pass through before any transfer.
Yeah. So now we will overwrite a default implementation, because in default implementation it is empty. Yeah, it is empty. It returns OK by default, but now we will override that, and we will use another feature of OpenBrush, modifiers. You can read about modifiers in documentation, but the main idea is that we will call some methods before execution of the main body of our function. So, for example, here we want to use OpenBrush for Pausable. OpenBrush provides two modifiers, when paused and when not paused. So, and we want to mark our before token transfer function with when not paused. So, if contract is not paused, that modifier will return OK. But if contract is paused, that modifier will throw an error that contract is paused. So you can.
Okay, this modifier is really like Ethereum Solidity modifiers, right? Where you add the modifier before entering the function.
Yeah. Also, if you want, you can, like in Solidity, you can specify that you want to execute a body of function. For example, in OpenBrush, we will first we will check that contract paused or not, and after we will execute a body. But if then you specify your own modifiers, you can specify, for example, firstly you want to execute body, and after you want to modify something.
Okay, so like if you want to do logic after executing the body, you can also use a trait definition for it.
Yeah. Modifier definition for that provided by OpenBrush.
Modifier definition, sorry.
Yeah. Okay, so now we.
Sorry, I have a bit of a newbie question here.
Transfer. Now
sorry, Green, can you hear me?
Method will throw an error if contract is not.
Yes, I can. I can hear you, Sasha.
Oh,
go on.
Yeah. So, what does it mean when we're using this functionality
and
of Pausable?
One more public method that will allow us to.
Green.
Yeah.
I don't know if can you hear us?
I hear you, but I am able to hear you, but I don't hear Sasha.
Oh,
okay.
My question is like, what does it mean to use this functionality Pausable, and what specifically like does it mean in terms of like storage and sort of deeper down, like what's going on, like for someone that's just new to this, like what does it entail, like, and what functionalities does it expose really?
Can I respond, Green?
Yeah.
So Pausable, Sasha, imagine you have a contract and you want anytime to have the ability to pause the contract, like really all transfer in the contract will be blocked for a certain amount of time. So it's a good security. For example, if a hacker starts to drain everything, you can really pause the transfer and then everything will be blocked until you release it. So it's just a Boolean that if it's true, it's paused. If it's false, then you can go.
And so who can call this?
Right now in our example, as I said in the intro, everybody can call it. But in real scenarios, only some people like predefined address or, for example, the deployer of the contract can call this function that, of course, is only for like administrators of the contracts.
Or through governance of sorts where, okay. And so is it an expensive call to make? Like what's happening with storage? Like
it would just change the Boolean in storage. So it's
okay.
It's the cheapest call you can do.
It freezes it. Yeah.
It's just it's just a Boolean, so it's not frozen. It's like when you will use the modifier when not paused. That means prior to every function like call, it will go through this modifier and check if the contract is paused or not. If it is, the function will not be executed. It's
Got
like
it.
pre-security before entering.
Cool. Super cool.
Is it clear?
Thank you. Yeah.
Okay, thanks.
Yeah. And now we plan to define a public method that will allow us to pause or unpause transferring. So we need to define a new public message. It should return PSP22 error or pausable error. It's how you prefer. OpenBrush also provides conversation between PSP22 error and PSP pausable error. So let me show what is PSP22 or PSP22 pausable error. Yeah, we have. Why it is not okay? PSP22 error. It's a list of errors what can be emitted by PSP22 account, and we also have pausable error. Here, pausable error. It is a list of errors that can be emitted by pausable contract. And OpenBrush provides conversation between both that errors, so we can easily convert one error into another. And here we want to, if our contract is already paused, then let's unpause it. Unpause. If it is unpaused, then let's pause it. Okay, it is two simple functions that will pause and unpause our contract. Yep, seems it is the full body of our USD contract for now. Let's try to build it. Yeah, it is built correctly. We will try to run test. Maybe let's try to run test now. I'm not sure, because we also need to implement the second contract before running tests. Because
let's try to implement wrapper first.
Yeah. Okay, and it says, oh yeah, another stuff. The latest Rust has a problem with check overflow. So it is workaround for now. You need to specify profile def check overflow checks false to be able to build your contract successfully. Release, but it can be disabled later. Then it will be fixed. Also, the latest ink. Maybe the latest ink already fixed that. I don't remember it. But for now, we need to use this workaround. Yeah, it started build process for integration tests. Okay, let's continue with wrapper TSD. We will check how our test build it. Okay, this wrap TSD, we do the same steps. Our wrapped USD, it is also PSP22. So we have the same template here, the same dependencies, but another name. It is a contract, so the create type is cdlib, and we will use a default implementation from OpenBrush for PSP22, so we also enabled that feature here. Constructor. Yep. So we also enabled that feature here. Here we have the same steps. We need to enable unstable feature. We need to define a no std attribute. Let's rename the name of package wrapped USD to be more correct. Yeah, we already copied that code from here, so the default implementation for PSP22 should be enabled. Let's try to build it. Wrapped USD. Let's wait for tests. And after we will continue with wrapped USD and logic for that contract. Okay, we built our contract successfully. Now you can see that free test for USD token was passed successfully, and free test for wrapped token failed because we don't have required methods. Let's check tests, what we try to test here. So we have free tests for USD token. The first one tested that the creator of the contract really got 1,000 tokens. So in setup contract, we created an instance of USD token. We called a new constructor function with arguments 1,000. As you can see, it is our initial supply. We minted 1,000 tokens for the caller of the contract. So that test verified that the caller really get his 1,000 tokens. The second test verifies that we are able to do a transfer. So we created the same contract. We checked that the balance of the creator is really 1,000. After we checked that the balance of receiver account is 0. After we did a transfer here, and after we verified that sender has 900 tokens and receiver has 100 tokens. So yeah, it was our second test. And the third test checks that we are not able to do a transfer, then contract is paused. So it is similar to the second test, but here we have additional step that we changed the state, and here we verified that transfer was rejected with that error. And here we verified that the balance didn't change after the transfer. So let's comment this line, these lines. There we overrided before token transfer method. So now after commenting of the lines, our contract our contract allows transfer tokens if it is not paused. And let's run tests again to verify that.
Basically, you make Pausable useless here.
Yeah, but I only want to show that we are changing really actual contract. We are testing and changing the same contract.
Okay, you prove that the tests are effectively working, right?
Yeah.
Okay.
It takes some time. Okay, we built USD token. Now we're building Rapid USD. Parapapam. Okay. Now you can see that should not transfer when paused was through an error, and here, the error is that we should be reverted. It because we expected that transfer will be reverted here, but it was not reverted because we commented the code here, and it failed. So it works. Okay, let's implement Rapid USD.
So implement deposit and withdraw, right?
Yeah. Let's check that the default implementation for PSP22 works. Yeah, it compiles successfully. And in README of current example, we already defined it at rate, which method should be implemented by wrapper contract, by wrapped USD contract. So let's copy that rate definition here. It uses brush. We are using brush rate definition, and Ink also provides its own Ink definition. For example, here. Ink trade definition. Under the hood, we are using Ink trade definition, but we also are adding some additional stuff which can improve user experience. So, for example, OpenBrush provides wrapper. Let's call it, I don't know, wrapped PSP texture. OpenBrush provides additional wrapper, additional macro wrapper. It allows developer to create a wrapper around some trade that can be used to do across contract calls. So I will show you later how we can use it, but it's why we suggest to use brush trade definition instead of Ink trade definition, because it generates some additional stuff that can be used later. Okay, let's implement that two methods. So impl wrapped PSP22 for contract, yes. Let's remove comments. Okay. The idea of deposit for method that someone will call that method the current contract, so wrapped contract will try to transfer some tokens. Oh, okay. We forgot to define one additional field. The idea of our wrapped PSP22 token is that we will interact with another PSP token. So we will our contract will hold tokens of another PSP22 contract, and will provide to users another wrapped tokens. So we need to store underline, let's call it token. We need to store an address of PSP22 token. In our case, it will be USD token account. Wait, sorry. And now we will transfer USD token from caller of the contract to our wrapped contract. Maybe let's call it wrapped contract to be more clear.
Also, Green, you need to create an internal function.
Yeah, I will add it later. I want to show explicit code. So, and here we will use a wrapper from OpenBrush that allows us to do cross-contract calls without knowledge about the implementation of the contract. For us, it is enough only to have a trade definition to do a cross-contract call. So, for example, PSP22 ref transfer from self underline token. It is account ID of the USD contract. And now we need from to value and data. So we want to transfer tokens from the caller of the contract to current contract. So it is caller. Caller it is who called that method, and account ID it is address of the wrapped contract. So we want to transfer tokens from that user to that contract. We want to transfer that amount of tokens, and we don't need to specify any data, so we can pass an empty vector here. And let's import include vec, and let's import that macro to generate the empty vector. So in that function, so here we will do a cross-contract call to PSP22 contract. The address of that contract is here, and here an arguments for that transfer. Later I will show you how you can do it not explicitly, how you can do it implicitly. But let's first finish the implementation of that function. So the first step is to transfer tokens to wrapped contract, and the last step is to mint the same amount of tokens for the contract specified during calling of that method. So mint function, first argument is receiver of tokens, and the second how much. Okay, so it is the full implementation of that method. So we transfer tokens from USD contract to wrapped contract, and then we mint a new amount of wrapped tokens for that account. Okay, let's create internal function. Internal functions. Functions. Yeah, let's call it wrapped. It will return a reference for PSP22 ref. So, and here, instead of explicit call, we can do implicit call, like wrapped transfer from. So, and maybe it's more readable than before. So the same idea we are using here, but first we need to burn the same amount of tokens, but not from account. We should burn it from color balance. Yeah, we will burn it from color balance. We will burn that amount. It will check if that enough of wrapped tokens on the balance of the color. If not, it will throw an error. And after, we need to transfer tokens to that account. So if we have enough tokens to burn from color balance, we will burn it. We will burn wrapped tokens, and then we will withdraw USD tokens to that account. Yep, seems it is right. I think yes.
Looks nice.
Okay, let's try to build it. Oh, okay, it requires explicit.
Yeah, and also in the constructor, maybe can you show me the constructor? You need to pass the account ID.
Oh, yeah, you're right. Thanks. Thank you. Yeah, USD account ID. Yeah, so self PSP22 default, and underlying token is the account. Yeah, now it should be more correct. So that wrapper can be used to do a cross-contract call to any contract that implements that trait. But we are not using it here, so I think we can remove it. It was only an example. We showed how we can use it for PSP22 ref. So it is wrapper around PSP22 trait, and it is enough to do a cross-contract call. Yeah, let's rebuild it again. Okay, it builds. Do we have some questions or not?
I think for now it's okay.
Okay. So yeah, seems we are able to build it correctly. Let's try to run tests. Okay, let's discuss about tests for wrapped contract. We defined 3 tests. So the first test verifies that we are able to deposit that Alice are able to deposit tokens to wrapped contract. So we verified, firstly, we verified that Alice has 100 tokens after Alice approved that wrapped USD contract can transfer tokens from Alice balance, can transfer 100 tokens from Alice balance in USD. After, Alice called deposit for function with amount 100. And after we verified that the balance of Alice in USD token contract is 900. And the balance of wrapped contract in USD token contract is 100, and the balance of Alice in wrapped USD contract is 102. So that means that Alice sent her 100 USD tokens and she got 100 wrapped USD token. Okay, test passed successfully. Let's check the second test. Here we are verifying that Alice are able to withdraw her USD tokens back. So we did the 3 initial steps. We got 100 wrapped USD token, and now Alice sends the transaction to wrapped USD contract, and she asks for withdrawing of her 100 USD. And here we are verifying that the balance of wrapped contract in USD token is 0. Also that the balance of Alice in wrapped USD token also is 0. And here we are verifying that balance of Alice in USD is 1000. So that means that we deposited 100 and withdraw 100 back, and now Alice got her USD tokens back. And the third test is more general workflow. Here we are verifying that Bob are able to withdraw deposited tokens, but how Bob got them? Initially, Alice deposited 100 tokens to wrapped USD after she transferred wrapped tokens to Bob, and after Bob withdrew the tokens back, and he got 100 USD tokens, but initially he has only 100 wrapped USD token. So let's check it more detailed. So we did initial 3 steps, and now Alice got her 100 tokens. After, Alice transferred her wrapped tokens to Bob. She transferred 100 tokens. After in test, we verified that the balance, that Alice balance in wrapped USD is 0, and we verified that Bob's balance in wrapped USD is 100. So transfer was successful. That means that transfer was successful. And after, we called a withdraw function from Bob for wrapped USD contract, and Bob tries to withdraw 100 USD tokens. We checked that the transaction was successfully, and here we verify that balances are updated. So we checked that the balance of Bob in wrapped USD is 0, and the balance of Bob in USD is 100. So that means that Alice transferred tokens to Bob, and Bob's are able to withdraw the tokens and get 100 in USD. So that shows that the full workflow works correctly. Yeah, so it is so tests are passed and everything works correctly. Now we will. It was we used simple structure in our project. We have only contracts and all logic defined inside of the contracts. But now we will show you two more structures that you can use in your project. Okay.
Cool. By the way, Green, you're getting a lot of love in the chat and in the question box. So keep it up. It's cool. It's cool what you guys are presenting.
Okay. Okay. So the idea of the next structure is that the implementation of our contracts define it on contract level, on trade level instead of contract. So let's create a new folder. Let's call it trades. Let's add a librs file here because it will be an entry point for a new project structure. So let's copy the definition of the package from here. Yeah, and let's oh no, sorry, not here, here. And let's modify it. Okay, let's call it example. I don't know. Example.
And wrapper example.
Oh yeah, let's call it wrapper. Oh, let's call it wrapper. Simple wrapper. Okay, and that package will be only used inside of our contracts, but we don't plan to create an instance of that package. So it is why we will use here rlib instead of cdlib. So let's remove this comment. So that means that we will import that crate like a dependency package, and we don't plan to instantiate a contract. So librs, it is entry point, and we want to add. Let's enable indexation. It enabled. It is already indexed.
Should you add also a configure attribute feature standard and not standard here?
Yeah. So let's add modrs here. Yeah. We will import trades folder. Trades folder contains modrs file, which describes everything related to implementation. So now let's define two additional files here. One will be for USD token, and another trade file will be related to wrapped USD. Okay. Oh, and also let's return back to cargo toml. And here we also need to specify our dependencies because we plan to use OpenBrush and ink-related stuff. So for that, we need to copy all the same dependencies here. And we plan to use default implementation for PSP22 and Pausable. So let's also Pausable import it here. Okay, we don't need this feature, so we can remove it. And yeah, so dependencies are the same. And here we change the crate type. So it seems okay. Here in mod res file, let's import USD token and wrap USD. So it is to our files that we added before. It's how the structure is created. So we define it. It is entry file for that folder. In that file, we described two additional files what we want to include in our project. So it is USD token and wrapped USD. It's how it is used in Rust. How it can be done in Rust. And here in librs we defined that entry point. The librs it is entry point for our crate, for our wrapper crate. Here we specified that. And now our crate contains traits folder. So let's define the implementation for USD token. In current example, our USD token doesn't has own logic. It only implements this stuff from OpenBrush. So let's only describe it here, because it will be more explicitly for users, for other developers who will check your the logic of your contracts. They will see that your contract, right definition, that your contract, let's call it USD token, let's call it, depends on PSP22 Pausable, that your USD token depends on PSP22 Pausable and Pausable traits. So it will be very clear, for viewers of your repository, that your USD token is simple combination of two default traits, PSP and Pausable. Also, you can define a wrapper here, like we discussed before, that people can use that wrapper to do across contract calls to your USD token. It is up to you. So that only simplifies the interaction with your repository, if you want to publish it somewhere. Okay, so let's we define it here. We imported everything here, and let's import it here. So our crate called wrapper, it has the next path here and here. Yes, it is right? Yes. So it is that package. You should import it with disabled default features, because it is a standard flow for no STD contracts. And here you need to enable STD features. So it is stuff related to Ink. Your contracts, Ink builds your contracts in two modes, in no STD and STD. So by default, we are importing another packages without in no STD mode, but then it requires STD, it will call STD. So okay, it is how we imported our new wrapper. Let's now we did it here in cargo toml of USD token. And now let's use it here. Instead of brush, now we can use wrapper, traits, USD token, and now we can import everything from here. Oh yeah, I forgot one stuff. Let's also export our imports. So yeah, now you can see it is visible. So it is in traits, we also imported and exported the implementation, the default implementation for PSP22 and Pausable. We also defined traits and wrapper to communicate with your contract. And it is empty trait, so you cannot implement that, but better to implement that, because in that case Rust compiler will verify that you're really implementing PSP22 and Pausable. So it's only a guard for you to be sure that your contract implement both that traits. Because, for example, if you will remove that, it will show that, oh my god, you not implemented PSP22. Okay, so it was simple for USD token. Now we can try to build USD token. Okay, it requires some time. And let's continue with wrapped USD. In case of wrapped USD, the main idea why we want to use another structure, because we want to move definition of that trait here instead of the contract body. So, oh yeah, and we also need to add this stuff to our crate here. Yeah, if you see an error like this, that means that you forgot to add this configuration. It is required by ink. Oh, okay. It says about. Okay, let's comment that for now, because we want to test USD token. Yeah. It builds correctly, so okay, we can continue with wrapped USD. We want to move definition and implementation of wrapped PSP22 here on trait level. So we will also move it here. But okay, let's do it step by step. So now we need that. We also want to import it publicly, because we also want to export that. Maybe not that. We will decide about this later. Okay. So our wrapped PSP22 depends on PSP22, so we want to force compiler to check that we also implement PSP22. And now we will try to define a default implementation here. But for that, we need to define a new trait. Let's define trait. Let's call it wrapped PSP22 storage. That trait has two methods. get, which will return a new type. We will define it later. And another method, get mute, which will return a new type. And now let's define a new type. Abstract, let's call it something like this. It will have only one field, underlying token. Let's copy it from here.
So Green, we are also moving the storage struct in this file, right?
Yeah, we are moving storage definition here.
Okay.
Use brush traits count ID. Yeah, and balance. Yeah, and here we will return ref on the data type, and here we will ref mute for that data type. And now we need to all fields that we will use in our contract should implement some additional stuff from Ink. For example, OpenBrush already implements that, and it requires implementing spread layout and storage layout in STD mode. So let's do the same for our new data structure. So it is the same. Default and the bucket is not required by. I suggest you to implement them by default, because it is not hard. But Ink requires you to implement spread layout and storage layout. So if you plan that some structure will be used like a field of your contract storage, so you should implement that to traits. We can derive the implementation for the traits because Ink provides a derive macro for the traits, so it is not. And here, let's return it. So it is. Yeah, it is only trait definition, but without implementation. And yeah, so it is only trait definition. And here we will use that trait to we will use that trait to get underlying token to do cross contract calls. So like we did it here, we did it here. So let's create the same internal function. Here, yeah. It will return the same PSP22 ref that allow us to do a cross contract call, but now we should use that trait to get an underlying token. So we define it a storage trait that allow us to get some storage fields. So that means that any contract that implement that traits also allow us to implement that trait. So now we can copy the implementation from here to here, and it should work. And from here to here, and it should work too. Okay, and I think we can remove it here. So to not define that trait by yourself, Brush, OpenBrush provides a macro. Brush.
I was waiting for this one, Green.
Okay, it provides the class storage trait macro.
Yes.
That will define the same trait. That macro has two inputs. The first one is the name of the trait, which should be defined. So let's copy it here. And the second one is the type that should be returned by that trait. So let's also copy that. So this trait and trait defined by this macro are equivalent to each other. Yeah, I think it is. Yeah, I think it is done. So let's go to cargo toml of wrapped USD. Let's also import wrapper, like we did it for USD token. So we need to specify path to that cargo toml, which is here. And we need to disable default features. So we need to disable std mode. And we need to enable it here. Wrapper. Yeah. And now, instead of it, we can use wrapper. Okay, it is not indexed at the moment, but it is in progress. Yeah, traits, wrapped USD. We will import everything. So it will import a default implementation for PSP22. And also we imported the wrapped PSP22, but it says that we didn't implement a wrapped PSP22 storage. So let's implement it now. So wrapped, let's PSP22, wrapped PSP22 data. So yeah, it is a new field of our contract. Inside it is underlying token, like it was before. And now we need to implement wrapped PSP22 storage trait for our contract. After implementation of that trait, we will have a default implementation for our trait. So you can see the implementation of that trait is very simple. And now
there's a question that came up that's probably relevant right now. Is there other data structures? The question is asking if there's other data structures that we can use to interface with the PSP22 storage, or does it have to be HashMap? I assume that it's an ink thing, and I'm not very familiar with the documentation, but I have a link here that might help.
We are using OpenBrush at the moment. Use storage hash map, but it is already deprecated in latest ink because storage hash map adds a lot of takes a lot of size. It increases the size of the contract very well, and better to use mapping from. Okay, I can change it. Better to use mapping from ink, but mapping only available in latest ink. But at the moment we can't use it because of the issue. It is described in our documentation. I forgot. There it is.
Interesting. So the answer is yes, we can use other data structures, and more specifically, OpenBrush is actually looking to use different data structures to improve on efficiency. I'm not so clear on what you meant by like what the alternative would be, but maybe you can post a link of that issue so we can have more context.
In our documentation, you can find the description that at the moment we're using ink RC6, and we can't use the latest ink due to this issue. But then that issue will be fixed. We will update OpenBrush to use mapping instead of storage hash map, because it saves a lot of space in context of the smart contract size.
Awesome. Yeah, thanks for the question, Diego.
Yeah, thanks for the question. So, and here we need now we need to we need to update our constructor, and here underline token. Yeah. So. Yeah, it should be public. So here we updated our constructor. We don't need that methods anymore because it is in trait. It is defined here. Yeah. Also, that implementation of that trait can be done by macro in OpenBrush, impulse storage trait. It has 4 arguments. The first one is the name of the trait. The second one is the structure name. In our context, it is wrapped contract. The third one is a name of the field in that structure, so it's wrapped. And the last argument is the type. So if you don't want to do it manually like here, you can execute that macro. It will generate the same code under the hood. Or if you want to use derive macro, so if you want to provide derive macro from your project, you can read about it, how you can do that in our documentation. So we described it in that moment, how the same how you can get the same implementation by derive macro. So it is what OpenBrush provides, but the idea is the same. So yeah, and now we have a default implementation for our trait, and if user wants, here can easily override something, so we can specify it here, but we don't need to specify now anything. So let's try to build that contract, because maybe we missed something. Also, we need to remove that because it will ink generates under the hood. Ink generates definition for account ID and for balance, so we can't import account ID and balance here because we will have 2 definitions of the same types. Oh yeah, and we need to import that type because we are using it here. It is definition for vector. And mint exists for mutable. Okay. It is here.
Is it maybe you missed a PSP22 internal trait? I don't know if it's needed on wrapped PSP22. Like you wrap PSP22, have PSP22 and wrap PSP22 storage, but also needs PSP22 internal, right? To get all the function from PSP22.
Yeah. Let's PSP22 internal, because Mint, it is part of internal. Yes. Mint. Yeah, it is part of internal. So also let's ask for additional restrictions here. So it should also implement PSP22 internal, provided by OpenBrush. Yeah, it is enough, and we can remove it because it is not needed anymore. Yeah, so now we moved the implementation from contracts body level to traits level. Now we have to traits level, yeah, and we also can override that implementation. Okay, it's built correctly. Let's run tests to verify that it still works. And how much time we have? Oh, okay, we're already out of time.
Sasha, it's a question for you. Do we still have 15 minutes?
We are over time by 9 minutes, technically. But if you guys wanna just power through, then I'm happy to support that. And I don't have anything after, so we can continue if you wanted to go through one more thing. There was one like high level question that was asked about comparing to OpenZeppelin, but maybe we can prioritize the live coding then rather than going into some high level stuff. It's up to you guys.
Okay, I think we can. We got a panic. What? Why? Oh, it says that something is not found for metadata. For what contract? For USD.
I say we power through. This is good.
Okay. If you have question, you can ask, because now we will wait for building of contracts, so it will take time.
Yeah, the question was, what's the development workflow of OpenBrush? I guess the question is asking how does it compare to OpenZeppelin, and probably the person asking this was wondering maybe design decisions that you made that maybe are similar to OpenZeppelin. I'm not personally familiar with OpenZeppelin that much, so I wouldn't know, but maybe you guys have a better insight.
In contracts, we decided that implementation on trait level allows user also to override some logic. It is can be useful if you want, in case if you want to reuse some implementation from someone. And what? It is why we initially we tried to provide an implementation that can be customized. So, for example, like we did it here in USD token, user are able to customize any function, define it in trait. So it is called in terms of library. So it is why we decided to do that. And also we decided to use traits because traits, it's like an interface. So you can easily communicate or interact with any contract if you know the interface of that contract. So if some contract implements some interface, it is enough to have an interface to communicate with that contract, because instead you need to know the implementation of that contract. And it is
And the traits, in a way, I mean, the traits are very much what defines the standard.
Yeah, and for example, PSP22, it is a trait, and it is an interface, and it defines the list of methods that should be implemented by contract. And it is enough to have the definition of that trait to communicate with any fungible token.
Cool.
Okay, now we need to identify why we have an error with wrapped contract when we try to compile it in context of tests. Yeah, it says something that it says that we can't execute. Okay, maybe let's try to remove workspace, because I think maybe Redspot have some problems with workspace and package at the same time. So for now, maybe it will be a workaround to remove workspace from here, because it is already a package. But and we also added workspace here to only, for example, in production project, or in any project, you don't need to have a workspace. So that should be a final structure, I guess. Also, we described differences between all solutions in our repository. So it has 3 branches with implementation of each structure. You also can compare any branches, so to find only differences. Yeah, now we will run tests. So because we removed workspace from here, that means that now we will use not this target folder. We will create a target folder for each crate separately, and it will take some time, because now we need to build that crate and that crate. Yeah, it can be optimized with cargo target dir, but we will discuss about it later. Maybe we will create a separate documentation with suggestion how you can speed up development process, because then you have a big project and it contains around 10 contracts. Without optimization, it will take a lot of space, because, for example, if you will build the whole OpenBrush without that optimization, it will take around 200 gigabytes of your hardware if you will not try to resolve that problem. So yeah. Okay, we are able to build USD token. Yeah, and now we are building wrapped USD. It will take some time. So let's discuss about next solution. In solution number 2, we moved all implementation and stuff related to trades in separate folder. We defined a default implementation for our trade. We defined a storage trade, which we used in our default implementation. So we extracted the logic to another files. In solution number 3, we will extract the implementation of that trade in separate folder. So here in trades, we will have only definition. We will have only definition of trades. but implementation will be in a separate folder. Let's create that folder for future. It will be Impulse folder. Yeah, and here we also need to create an entry point for that folder. It is Modifiers. And here we also need to create a folder for wrapped USD. No, not folder, file for wrapped USD, and for USD token. So the same structure like in trades folder. USD token. Yeah, and now let's include it here, Impulse. Now let's include it here. Oh, okay. Contracts, yeah. So you can see that after refactoring, our test compiled and executed successfully. So we didn't break it. So it's okay. It's cool. Yeah. So let's continue refactoring. So now in mod rs, we need to include wrapped USD and USD token files. Yeah. So we need to open it. So again, with USD token, we don't need to do anything because it is a simple contract. But let's OpenBrush provides trades and provides contracts. So contracts, trades. Yeah, OpenBrush provides separate trades and implementation for that trades. So trades are defined in brush contract trades and the name of the contract what you want to use. So it has a definition. But if you want to use implementation, you need to use that way, that path. So now in trade, we only want to import trades, not default implementation, related to our USD token. And in Impulse here, we will import implementation for USD token. We will import implementation of PSP22 and Pausable. It is up for developer to have implementation of USD token like this, because we don't need to do that because it's only imports and exports some stuff. But it's up to developers. So and let's here use import and export trades for USD token. Yeah. So now then we will import why it is not included. It should be included here. Oh, okay, it's not included because I don't know why. And now here we need to do something like this. So impulse mode of USD token now imports the default implementation for PSP22 and Pausable, and also it imports it imports USD token trade definition and USD token ref wrapper definition. So now here we can use this. Maybe not here. Let's here. Yeah. USD token ref, and we also we have a default implementation for Pausable and PSP. It's only an example how you can manage imports and exports. Okay, and let's come to wrapped USD. That is more interesting for us. So let's copy everything here and paste it here. And now let's remove all stuff related to implementation of that trade. Let's remove it. So now we have only trade definition here. Let's do the same here. Let's only import stuff related to trades, and let's define a wrapper. Brush wrapper type. Okay, so now trades folder contains only trade definition of each contract. So if someone want to interact with your contracts with that project, for example, it is enough for him to only import that grade and use trades defined here to do across contract calls with your contract, with your contracts.
So he will ultimately reduce the size of his contract because he's importing less code, right?
It can speed up the compilation process, but it will not affect the size of the contract because Rust only include the code that it only include not that code. So that will not affect the size, but the idea is that you can define trades in a separate crate, like we did it here. And now for user is enough only to import that crate, this thread with the trades.
Okay. So
that contract directly incas dependency to your contract, because we for other developers will be enough only trade definition to interact with your contracts. Okay, so we removed all stuff related to implementation from here, and now we will use it here in impulse section. So let's import default implementation for PSP22. Also, let's import trades for our wrapped USD. Account ID balance we are using. It's also yeah. So the data structure has the same definition. We don't need to change it. The storage trade also has the same definition. We still plan to use that trade. And here we will use a default implementation. Oh, yeah, and it also requires us to use of unstable. Okay, no matter, we can use it or we cannot use it. It will not affect us. It only affects the final contract. So, and here we will create a generic implementation for the contract. So here we are defining a generic implementation. We want to implement wrapper PSP22 for some generic type, and that generic type has next restrictions. It should be PSP22, it should be PSP22 internal, and it also should be wrapped PSP22 storage. Also, we can remove that because we can remove that because we are requiring that here. Yeah, and now we need to mark that implementation like default. That means that if you want to overwrite it, you can. So that means that you can overwrite that implementation if you want. If you don't override that, then compiler will use that implementation by default. So we also remove inc messages because they are required only in only during trait definition. In implementation section, you don't need to specify it because it is already specified in trait. And now we also want to in that generic implementation, we can't add additional methods because it only should have method defined in trait. So, for example, here we want to have one additional internal function, and for that case, let's create an additional trait. Let's call it wrapped PSP22 internal, and that trait will contains only that function. And let's also create a default implementation for that internal trait. So it will has the next syntaxes. And here we are. So we also implemented that trait for any generic type that implements rapid PSP22 storage. And we can use that method here because we know that subset of restrictions of that that set of restrictions of that implementation is subset of restriction of that implementation. So because we know that that generic type implements that trait, that means that it also has that implementation, and it is why here we can use internal method from here. Okay, so it is publicly imported here, it is publicly imported here, and implementation is also public. So we can use it here, and it should be enough. Yep. let's try this. Let's try to build it. So the main idea here is that we moved everything related to implementation in impl folder. And traits folder contains only definition of methods of our contract. So, and it is and trait definition is enough to communicate with your contracts. In big project, that structure allows you to okay, we build it successfully. Let's run tests. In big project, that structure helps you to not have problems with interactions across your project with your contracts. It allows other developers to easily communicate with your contracts if they want to do that, because traits define it separately. And also you can override your implementation, and you can try to yeah, you can override that, and maybe it's all. I don't remember. We described the list of features that is resolved by that structures. Yeah, we described it here. Yeah, the body of contracts is looks much simple. Yeah, we only have the list of trait implementations, and maybe we have some overrides here instead of implementation of each method here. So it reduces the size of the body, of the contract body. That also is cool. Yeah.
Hey, Green, can you precise that this now in the documentation that this OpenBrush example is really like the folder structure of a production-ready project?
Yeah.
And that we have an extensive example.
Yeah. So, yeah, we can see that our test passed successfully. So everything works correct. Yeah. In documentation of OpenBrush, we have a separate chapter. It is called OpenBrush example, and here we described the whole process, how you can manage the structure of your project. So it has 4 contracts with borrowing lending logic, and we described how which structure better to use, how you can implement each folder. So it contains the same idea that trait folder should contain only trait definition, impulse should contain only implementation, and contracts folder contains a separate grades with 1 contract for each grade. And it also describes the idea with storage grade, with derive macro, with data structures, with default implementation in traits, or with generic implementation. So it covers both cases and describes pros and cons of each. And also how better to manage your errors, because if you have a lot of contracts, you also have a lot of different errors. Yeah, so if you want to get more info about that, you can read our documentation. So yeah.
Thanks.
And I think it's all. I can.
Cool.
For example, I can remove mint method here to show that it will fail. That test will fail. But yeah, I think we finished. If you have let answer on them.
Yep, thanks for that demo. That was really extensive, and I think it'll be useful for people who are also looking to start building using the OpenBrush library, to go back and listen to this video. That's why I was encouraging you guys to just finish the different examples. And yeah, for reference, those that are watching on YouTube, if you go to the Crowdcast link, you'll see a bunch of links that we've been sharing in the chat. Most notably, the link to the repo with the solutions in the different branches. So I highly suggest that you guys check that out as you're going through this video. With that said, Pierre, Green, do you guys have any things you want to mention for developers getting started with building with Ink? Maybe a little note on the standards that you guys have implemented, and sort of using the OpenBrush library really to sort of be kind of future-proof, right, as we're building out the ecosystem of smart contracts.
Yep, here.
Okay, yeah, we already have done PSP22, which is a token standard. And in the next months, right now, we are preparing NFT standard and multi-token standard. And of course, OpenBrush will all time implement the reference of what is described on the standards. So we are working on the standard area and also on the implementation area.
Yeah, and we hope that then we will create a PSP for NFT and for multi-token. We will wait for comments from the community, because it is important to know.
And where's the best place for the community to reach out to you guys, other than using GitHub?
We have an element channel that is described in our GitHub section, exactly like Ink does for, like Parity do for Ink. We have also dedicated a channel in Element for any question. We are really active there, so please do not hesitate to ask any question there.
Awesome.
Example doc. We also have a generator here, and you can enable some extensions for example, PSP22, like openable, and you can check how you can import that. And also here we have a link to our channel. Yeah, here. Link to our element channel. So if you have some question, you can go there and ask.
Yeah, I really like that feature actually on your website, what you're showing right now with the different extensions. What did you guys build that in?
I can't answer on that question because it was implemented by our front-end developer. It used React under the hood, but what exactly, I don't know.
It looks really cool. Yeah, I should check it out. Definitely a cool little feature for any docs, especially in this.
Yeah. So, yes.
Cool. Well, thank you so much, guys, for taking the time really to go through this demo and show all the different pieces and like capabilities of OpenBrush. Well, I'm really excited to just keep an eye on different developers building and making use of these cool tools, and also I'm feeling lots of different like collaboration between the Ink team and you guys. So as a Parity guy, I'm stoked on that too.
And thank you, Sasha, for your invitation. It was really a pleasure for us, and I think we wanted to do this since 3 or 4 months already. So today was the D-Day, and thank you for that. Really.
Sweet. Always. Well, you guys take care and have a great rest of your day.
See you. Thanks.
Thanks, Green. Thanks, Pierre.